In this session, we will discuss about queue data structure. A queue is a linear data structure in which an element can be inserted only at one end called rear end, and elements can be deleted from the other end called front end of the list. So observe this diagrammatic representation. In queue data structure point of view, both ends are open ends. One end allows insertion operations and one end allows deletion operations. Here, rear end allows insertions, front end allows deletion operations. Such a representation is known as queue data structure. Now these are examples: ticket issuing counters, vehicle entry in a single route, printing multiple programs on a printer. So these are all generalized examples of queue data structure. Now, a queue is also known as FIFO list, first in first out list. Here observe this one. Consider 4 elements 10, 20, 30, 40. When these elements are inserted into the queue, now the insertion order is 10, 20, 30, 40. When the elements are deleted from the queue, now the deletion order is 10, 20, 30, 40. Here 10 is the first inserted element. Now first 10 is the deleted element. So the first inserted element is the first deleted element. Hence, a queue is also known as FIFO, first in first out list. So in queue data structure, the order of deleted elements is same order in which they were inserted into the queue. Now, representations of a queue. So as similar to stack data structure, queue can also be represented in two ways, like array representation and linked representation. First one, array representation. So the static representation of a queue uses arrays concept. Now assume queue is an array used to represent a queue with a maximum size as n. Initially, elements are not available in the queue. At this stage, the two variables front and rear are set at -1 position. This example, consider n equivalent to 4, that means size of the queue is 4, and two elements 10 and 20. When these elements are inserted into the queue, then the status of the queue is this one, diagrammatic representation. Here these two elements are inserted into the queue. So the front position element is 10 and rear position element is 20. The second format, linked representation. Dynamic representation of a queue uses linked list concept. Here, as similar to stack, here also we use single linked list to represent queue data structure. So in single linked list format, each node is divided into two parts as data part and link part. Data part stores information part of the element and link part stores address of the next element. Now it shows the diagrammatic representation of linked representation of a queue. Then abstract data type queue. So in queue abstract data type, instances is linear collection of 0 or more elements, and the supporting operations are enqueue, dequeue, front element, rear element, is empty, is full, and display operations. Now the concept, types of queues. Now, based on the way of performing operations on a queue, queues can be classified into 4 types like linear queue, circular queue, deck, and priority queue. The first concept, linear queue. A linear queue is a linear data structure in which elements can be inserted only at one end called rear end, and elements can be deleted from the other end called front end of the list. Now it shows the diagrammatic representation of a linear queue. Operations on linear queue. The basic operations on a linear queue are enqueue, dequeue, front element, rear element, empty, fill, and display operations. Now to implement these operations, assume Q is an array used to perform linear queue operations with a maximum size as n. Initially, elements are not available. At this stage, f and r, these two variables represents front and rear elements of the list. They are set at -1. Here the first operation, enqueue operation. The process of inserting an element into the queue is known as enqueue operation. For every enqueue operation, first, rear variable is incremented by 1 and then new element is inserted at rear position of the queue. While performing enqueue operation, if empty locations are not available, then the status of the queue is referred as queue overflow or queue full. Algorithm enqueue of X. This procedure inserts a new element X into rear position of the linear queue. The procedure, first we check whether the queue is overflow or not. For this, if R reaches to n-1th location, then we print a message as linear queue overflow, written from the function and if the condition is false, now R equivalent to R plus 1, rear is incremented by 1. Step 3, Q of R is filled with X. If F equivalent to -1, then F is set at 0th location and if. Step 4, return. So this one enqueue operation. Next operation, dequeue operation. The process of deleting an element from the queue is known as dequeue operation. For every dequeue operation, first delete an element from front position of the queue and then front variable is incremented by 1. While performing dequeue operation, if elements are not available for further deletion, then the status of the queue is referred as queue underflow or queue empty. Algorithm dequeue. Function is used to remove the front position element from the linear queue. Step 1. If f equivalent to -1, then print a message as linear queue underflow, written -1 and if. Step 2. First access front position element. So k equivalent to q of f. Step 3. If f equivalent to r, that means if the queue consists only one element, then F and R set at -1. Otherwise, else. Now F is incremented by 1. And if. Step 4. Return K. Next operation, front element operation. This operation is used to print front position element of the linear queue. Algorithm F element. Function returns the front position element of the queue if exists, otherwise function returns -1. Process of checking. If F equivalent to -1, then that means elements are not available, so return -1. Else, if elements are available, return Q of F. And if. Next operation, rear element operation. This operation is used to print rear position element of the linear queue. Algorithm or element. Function returns the rear position element of the queue if exists, otherwise function returns -1. If R equivalent to -1, then return -1, else return Q of R. And if. Empty operation. Empty operation is used to check whether the queue is empty or not. Algorithm empty. Function returns 1 if the queue is empty, otherwise it returns 0. Step 1. If F equivalent to -1, then return 1, else return 0. And if. Next operation, full operation. Full operation is used to check whether the queue is full or not. Algorithm full. Function returns 1 if the queue is full, otherwise it returns 0. Implementation. If R equivalent to n-1, then return 1, else return 0. And if. Next operation, display operation. Display operation is used to print elements of the linear queue. Algorithm display. Implementation point of view. First we check whether elements are available or not. So if F equivalent to -1, that means elements are not available, print a message as right linear queue empty. Otherwise, else. Now elements are available from F to R. Hence, repeat for I equivalent to F to R, do steps by 1, write Q of I, and repeat. And if. Now step 2, return from the function. So these are the different types of operations that can be applied on a linear queue. Now, finally, the disadvantages of a linear queue. Now assume at one particular stage the status of the linear queue as, let this one. Here the size of the queue is 5. Now we insert some elements into the queue and we perform deletion operations. So at this time, assume the status F points to index 2, R points to index 4. So at this stage, if we try to insert an element into the queue, here R reaches to n-1th location, hence it prints a message as queue overflow. Now remember students, overflow means empty locations are not available. But when we observe the status of this queue, still empty locations are available at the front end of the queue. Now this type of problem is referred as false overflow situation. So at this stage, further insertion is not possible. So the main disadvantage of linear queue is If R reaches to n minus 1th location, still empty locations are available at the front end of the list. Now those locations are not possible to utilize in linear queue. Now to overcome this disadvantage, we go for another type of queue known as circular queue. Thank you one and all.